Welcome back to Aurora Tech Channel. Today, I will show you how to set up multiple instances on Klipper with the BigTreeTech Pad 7 or the CB1. The CB1 is a Raspberry Pi replacement board and is combined with the Pi 4B adapter to make it work as a Raspberry Pi. Getting something like this costs around $50, and like the Raspberry Pi, you also need to get a USB-C charger and a spare microSD card to get started. You can also just plug the CB1 right into the new generation of BigTreeTech motherboards like the Manta series I previously tested. The Pad 7 combines the CB1, Pi 4B, and the heatsink with the touchscreen and packs everything into a case. The package also comes with accessories like an accelerometer for input shaper calibration, a 32GB microSD card with the system OS pre-installed, and a power supply that allows you to use it right out of the box. This Pad 7 costs around $130. Compared to the other options in the market like the Creality Sonic Pad and the FLSun Speeder Pad, the Pad 7 is a little bit cheaper. But it doesn't come with an eMMC chip, so there's no onboard storage, and you have to run the OS system on the microSD card. This can be both an advantage and a disadvantage, but I will talk more about this when I show how to set it up. The Pad 7 has 3 USB ports, and the CB1 has 4, so you can control multiple printers with them. If you're worried about it being difficult to configure the Pad 7 or the CB1, I will show you every step in this video, as well as how to set up multiple instances. As regular bed slingers like the Ender 3 are not ideal for high-speed printing, after setting up Klipper, I will also try to upgrade the motion system, cooling, and extruder to see how fast I can push it to print. I would like to thank BigTreeTech for sending me all of this hardware, and with that, let's get started. As both the CB1 and Pad 7 don't come with an eMMC chip, the Debian Linux OS has to be run on a microSD card. If you're using the Pad 7, it comes with a 32GB one and is preloaded with the OS. But if you're using the CB1, you need to use your own microSD card and download the image from their GitHub page. Anyways, to make sure the system image is the latest one, I will still download it and flash it to another microSD card. The latest version is 2.3.2, which was recently updated on March 5th. I will download the complete version, which has Klipper and all other drivers pre-installed. Then, open the Raspberry Pi imager. In case you don't have it installed on your computer yet, I put its link as well as everything you need to download under the description. Choose the OS, select Custom, and open the image file we just downloaded. Choose the storage, and just write and confirm the target drive will be erased. After a while, it's done, and it ejects the card from the system, so we have to reinsert the card and take a look at some files. If you're using a CB1 without a screen, you need to edit the system.cfg file to enter your Wi-Fi information. Comment out the hashtag and put your SSID and password here. Save the file and insert the card into the CB1, and you should be able to find it on your Wi-Fi network, but remember to connect the antenna or it won't work. For the Pad 7, we don't need to change anything, and you can just insert the microSD card and turn it on. It boots up successfully and shows an error message, but this is because we haven't configured any printers yet, so you can just ignore it. Go to the menu and set up your Wi-Fi here just like how you would connect a cell phone to your Wi-Fi. However, like most 3D printers and small internet devices, this module only supports 2.4 GHz networks. After that, we can open the browser and use the default hostname, which is btt-cb1.local. The mainsail web interface shows up with the same error message on the touch screen. The default image file also supports only one machine, so we need to log into the Linux system and reinstall Klipper with multiple instances. You can use any SSH client like PuTTY or MOBA Xterm, and I will also put the link below. I will use PuTTY to connect to the pad. Type the hostname btt-cb1 and use the default username and password, which are both BQ. Then type ls-l to list the files inside our home directory. As you can see, there's Klipper, the Moonraker API web server, the mainsail web interface, the crow's nest webcam utility, and a mainsail keep alive tool called Sonar used to avoid connection losses. Since we are going to uninstall them and reinstall multiple instances of Klipper, we need an installation tool, so we don't have to manually type a lot of commands. But we still need to type a few lines to install it. Type sudo apt-get install git-y. If git is not installed, it will install it, and if it is already installed, it will update it to the latest version. Then, we can use git clone to install Cura, which stands for Klipper Installation and Update Helper. Just copy and paste the command from the video description. Next, just copy the command from the video description and paste the command to start Cura. As you can see, by default the system has one instance of Klipper, one instance of Moonraker, the mainsail web interface, the Klipper touchscreen UI, and the crow's nest webcam utility pre-installed. Type 3 to remove them. I will remove Moonraker first by typing 2. Use B to go back, and you can see that Moonraker has been removed. Next, I will remove Klipper. I will also remove mainsail as I personally prefer fluid. If you're using a CB1 without a touchscreen, you do not need KlipperScreen either. I also don't use a webcam with the CB1, so I will remove everything and reinstall what I need. Okay, everything is now gone. I will start by reinstalling Klipper by typing 1, 1, and 1 to install Python 3. Then, we need to enter the number of instances to set up. For the Pad 7, as it has 3 USB ports, I will type 3. For the CB1, it actually has 4 ports, so we can install 4. In fact, there is no physical limit to the number of instances. If you use a USB hub, you can install more than 4, but as the processing power of the CB1 and similar Klipper pads is not that high, it would be safer to run only 3 to 4 instances. We can just assign custom names. If you've already decided which printer to connect, you can enter the actual name, but I will just type printer 1, 2, and 3 for now. After the installation of Klipper is finished, we can go back to the main menu. It will now show that 3 instances were installed. Next, we will install the Moonraker API web server. We also need multiple instances of Moonraker. We have 3 Klipper instances, so the number of Moonraker instances will also be 3. Okay, let's go back to the main menu, and we also have 3 instances of Moonraker installed. I prefer Fluid for the web interface, but if you like mainsail, you can install that, so this is just dependent on personal preference. We also want to download the macros. Okay, go back to the main screen, and if you're using CB1, you're done. As I am now setting this up on the Pad 7, I also want to install the KlipperScreen touchscreen interface. Now we have everything we need. You can type sudo reboot or just turn the pad off and back on. The screen is working, and when we log back into the terminal, we can see that multiple instance folders are here. Next, I will change the hostname to a different name instead of BTT-CB1, as I have multiple CB1 devices installed on my network. If this is your only CB1 device, you can keep the default hostname and skip this part. Take a look at the boot directory under the root, which contains the same thing as the files you saw when you read the MicroSD card with your computer. We can simply edit the system.cfg file by typing sudo nano/boot/system.cfg, and we can change the hostname and other settings, such as screen rotation, sound, and vibration. I can even turn on the vibration so that the device provides feedback when I touch the screen, which is pretty cool. Let's reboot the system for these changes to take effect. After the reboot is complete, we can use the new hostname to connect to the web interface. We installed 3 instances to control 3 printers. The first one is already added, and it will use the default port, Moonraker API port 7125, so we don't have to specify it. Then, we can manually add the second and the third. For the second one, use the same hostname, but this time add port 7126. For the third one, the port number will be 7127. We can now switch printers using the menu. You can also rename it to whatever is easier to remember or the actual printer name. Okay, all three printers can now be selected from the web interface. If you're using the Pad 7, when you look at the touchscreen, there's currently no way to switch to different printers, as we still need to set up a ClipperScreen.conf file to tell the UI that we have multiple printers. Let's log back into the terminal. Okay, we will create a file in our home directory. Type sudo cat ClipperScreen.conf and just copy the command from the video description. Press Ctrl D to exit, as we want to type everything using an editor. Now, type sudo nano followed by the file name we just created. If you want to set a default printer, you can put these 2 lines of code and then give the details of the first printer. For the second and third printer, the information will be the same except for the printer name and port number. You can copy and paste the whole file from the video description. Okay, type sudo service ClipperScreen restart. You will see that the touchscreen UI is restarting. Now you can see a new button is here. Click it and it will let you switch to different printers. The installation on the CB1 is done. Next, we will change the firmware on our 3D printers from Marlin to Klipper. You can use the tool inside Cura to generate the bin file, but you have to select the correct options like the processor architecture, the model, the bootloader offset, and the communication interface. However, if you are using a more popular machine, you should be able to easily find ready-to-use firmware and a config file online. I have several printers using the Creality V4.2.2 motherboard, and all of those machines use the same firmware bin file. Just copy it to the root of your printer's microSD card, and it will flash the firmware. Turn it off and back on, and it will show a blank screen. But don't worry, as Klipper supports classic LCD screens. This screen will work after we copy the printer.cfg file. The printer.cfg file is used to configure different printers. For commonly used printers, you can find the config file on the Klipper official website or use files shared by other users. I have edited the config example to fit my Ender 3 Neo, which is basically an Ender 3 Pro with a CR touch. If you have an Ender 3 series machine that uses a V4.2.2 motherboard, you can directly use this file. I will copy everything and go back to the web interface, go to configuration, open printer.cfg, delete everything, and paste my file here. The most important thing you need to configure is the port. This Pad 7 has 3 USB ports, and I've already listed them here. As my first printer is connected to this side USB port, I will just leave this line and comment out the others. Save and restart. If there are error messages, we can just follow them to fix them one by one. Okay, it says mainsail.cfg does not exist, but of course it doesn't as I'm using fluid instead of mainsail. So, go back to the config file and delete this line so it won't include the mainsail file anymore, and save and restart. It now shows MCU RPI is unable to open SPI device. I used an accelerometer before, and now it's not connected, so go back to the config file and comment out all the lines related to the accelerometer. Save and restart and see what's next. Okay, there are no more error messages. Let's home the machine and see if everything is working. Okay, it's working fine. I will rename it to my actual printer name, and we can now set up the second printer. Go to the menu and switch to printer 2. I will repeat the same process and flash the same firmware file to this Ender 3 as is using the same Creality V4.2.2 motherboard. After that, we can open the config file for printer 2, delete everything, and paste in our own. As we already know the mainsail.cfg will cause an error, I will delete it. For the USB port, I use the back top port, so I will use this line. For the virtual SD card directory, as this is printer 2, I will change it to printer2_data. Finally, comment out these lines for the accelerometer and save and restart. This time it works without any errors. Home the printer and it's also working fine. rename it to the actual printer name, and we can simply switch between printers from the menu here. For the touchscreen interface, if you want to rename it, you can log back into the terminal and edit the ClipperScreen.conf file to include the printer names. You can also set a default printer so that the touchscreen will display it by default. If no default printer is defined, the touchscreen will show the printer selection menu every time it boots up. Let's restart the Klipper screen. As you can see, it boots up to Ender 3 Neo as it is my default printer. We can also use this button to bring up the menu, and the printer names have been updated as well. When we home different printers on the touchscreen, it will respond accordingly. If you have the Pad 7, it comes with an accelerometer that you can use to calibrate the input shaper. Before you can use it, you need to connect it to the back of the SPI port of the pad and enable those few lines that were commented out earlier. I will start with the x-axis. I will tape the accelerometer onto the print head using some Gorilla Tape. The default value is from my printer.cfg file, which I used to calibrate with another Ender 3, so I will redo it, and Klipper will reselect the best shaper type and values based on the calibration. The x-axis is done. It changed to the MCV shaper type, and the value is lowered a bit compared to the previous one. Now, I will tape the accelerometer onto the bed and start y-axis calibration. After it's done, the shaper type was also changed to MZV and the value lowered a bit. If you need to calibrate another printer, just move the accelerometer and repeat the same steps. Both printers are now ready. I use the Moonraker web API plugin in Cura to send jobs directly to the printers. And you will see a new button when you go to Manage Printers and enter the address of the printer. For example, if I want to send the job to the Ender 3 Neo, which is my default printer, I can just type the host name with or without port number 7125. If no port number is added, it will send to 7125 by default. If I want to send the job to my second printer, the Ender 3, I will put 7126 instead. As the Klipper screen supports the Ultimaker format thumbnail, we can also change the form to UFP with a thumbnail. As I will print at high speeds, I will increase the nozzle temperature to 230 degrees Celsius and the bed temperature to 65 degrees Celsius. The speed is set to 250 millimeters per second, and the acceleration is set to 5,000, except for the first layer, which is set to 1,000. The estimated time is inaccurate, as I'm using a stock Ender 3 profile. It was limited by the parameters of the definition of the printer profile, but it should still be able to print at around 120 millimeters per second. Let's send the job and see. Both printers are working fine, and the print finished in 55 minutes. The surface on both printers is quite clean, the input shaper is working, and the cooling of the stock Ender 3 is slightly better than the Ender 3 Neo. As the fan duct design of the Neo is more concentrated, it actually cools better when printing at normal speeds like 50 to 60 millimeters per second, but for high-speed printing, the old Ender 3 fan duct actually works better. Then, I will just move the MicroSD card to a CB1. As the Pad 7 is a CB1 plus a touchscreen, the system should work the exact same. For the Ender 3 Neo, I will connect it to the bottom left port. As we need to find out the port, we need to log back into the terminal. When we're using Windows and we plug in a device, it will show up in the Device Manager. For Linux, it will show up in a directory. The directory is located at the root and it's called dev. Inside the dev directory, we have another directory called serial. If we go to the folder and list the files, you can see a new port name here. Just select it and right-click to copy the name. We can then go back to printer.cfg and change it. Okay, save and restart, and it should be working. For the second printer, the Ender 3, I will connect it to the top left port. When we check the folder again, it will show a new port. We can do the same thing, copy the name, and update the printer.cfg file as well. Okay, it seems both machines are working. I will just home them using the web interface as we have no touchscreen with the CB1. This time, I will use a custom FFF printer profile with the same settings to reslice the benchy. The FFF profile should be faster than those Ender 3 profiles. The print's finally finished in 40 minutes. The results are still pretty good, except that the cooling issues on the Ender 3 Neo are more obvious when the speed goes up. I was planning to do some upgrades on the Ender 3 Neo, and I'll just do them now and see if there are any improvements. I installed linear rails on the Y-axis and the X-axis, as well as the BQ-H2V2S light high flow rate extruder. This extruder only comes with 0.6mm nozzles, and its claimed flow rate goes up to 45 mm per second cubed, which is higher than most extruders on the market. I've also upgraded the cooling fan to a 40-20 blower. As many components have changed, I have to recalibrate the input shaper of both the X and Y axis. After trying different materials, I got both good and bad results. The extruder's flow rate is so high that a normal 40-20 or 50-10 blower just can't keep up with it. To address this issue, I installed an extra large 120mm 20-watt fan to provide an excessive amount of cooling. I even removed the part cooling fan and just let the strong 120mm fan do its job in order to make the tool head even lighter, and this setup worked pretty well. As a result, I was able to print a benchy in 23 minutes with good results. I can also print with the 0.6 nozzle at 250mm per second with a 5K acceleration without issues. The 0.24 layer lines are also clean. I'm pretty happy with all of these upgrades. It's not quite a Bamboo Lab X1, but I would say it's better than most bed slingers that claim to print at 250mm per second. Since this video is for the Pad 7 and CB1 Klipper multiple instance setup, if you want to learn more about my H2V2S LTE extruder upgrade, just let me know and I may make another short video to discuss the details. Okay, as this video is more like a tutorial of how to set up multiple instances with Klipper, but as I have tested out a few different Klipper pads and used Raspberry Pi to configure Klipper, I would like to share what I think about the BigTreeTech Pad 7 and the CB1. The Pad 7 is the cheapest touchscreen Klipper pad option in the market. It's $20 to $30 cheaper than the Creality Sonic Pad and the FL Sun Speeder Pad, but it doesn't come with the eMMC onboard storage, while the FL Sun Speeder Pad has 16GB and the Sonic Pad has 8GB. Therefore, you must insert a microSD card and run the OS system on it. Generally, both eMMC and SD cards wear down over time, but eMMC should still last longer than SD cards. The good thing is you can swap the microSD card to switch between systems, just like how I configured the microSD card on the Pad 7, and it will work on any CB1 device. You don't need to reflash the eMMC to upgrade or change to another OS. If you use multiple CB1s or Pad 7s to manage your printer, setting up one system and duplicating the microSD card for multiple devices is pretty convenient. The downside of both the CB1 and the Pad 7 is that they only have 1GB of RAM, the same as the FL Sun Speeder Pad, while the Sonic Pad has 2GB of RAM. So, if you plan to control up to 4 printers, or you already have multiple Creality printers, the Sonic Pad with 2GB of RAM may be the safer and easier option. But if you have printers of several different brands, using the Linux image file from BigTreeTech allows you to configure anything you need. Of course, you do need to have some knowledge of Linux. As the CB1 is the same as the Pad 7 without the touchscreen and doesn't come with an accelerometer, if you have over 10 printers, getting a Pad 7 and multiple CB1s to manage them would be a cost-effective option. You can do the same with the FL Sun Speeder Pad or any devices like an old computer that run Linux using the same method in this video to make them work pretty similarly. Anyways, I put everything you need to download and every command you need to type under the video description. I hope you could find this useful, and that's all I wanted to share about this machine. If you found this video helpful, please consider giving it a like and subscribing to our channel. Thank you for watching, and I will see you next time.